Okay, in this video, we're going to explain a myth. A myth that frequency is not voltage. That's a myth. And frequency does not have a potential. That's a myth. When you look at harmonics, you back in the harmonics with the volts. There's your math. But let me show you the empirical data on that. This video is primarily for me because even I get myself into a little bit of a conundrum once in a while. But I understand it at least enough to recognize it, so I'd like to share that with you. Okay? First, we're back on a standard power supply. I've always said this. Just give me straight voltage coming in. I don't need frequency coming in. Okay? That's not necessary. And it's not beneficial, to be honest with you. So here's the frequency of hertz, DC or AC off the power supply. Okay? Now we're going to leave it there for a moment. We're going to come over here. This meter and this meter are on the superconductive side of the circuit. The blue is negative, the red and purple are positive. We're firing this light bulb, pardon me. It's a 1500 watt light bulb. Okay? It's at temperature almost. It will be in a moment. With just two and a half amps and 50 volts, 47 volts. So there's my input volts. There's my output volts. With this motor running and this light running. Okay? This is the understanding of amplifying superconductivity and the relationship between 1 watt equals 1.6 blah, blah, joules, which ties directly into 1.6 ohms of graphene. Okay? We stay there, even though I know that my circuits are at micro point 00743. I'm sorry. Give me a moment. Just give me a moment now that I have this on my mind. Okay. We know that the ohms, this is a cascading Wheatstone bridge. So we can go down to very, very, very accurate fine ohms. Okay? So these are my ohms. Okay? Once again, those are my ohms. That is clearly the definition of superconductivity. Okay? I'll deal with that in a minute. It's back over here to this mess of spaghetti. Okay. So now we just say 1 watt is roughly 1.6 joule, roughly 1 volt. Even though those are not tied together, and it would be a meaningless question to ask how many hertz are a volt, okay? Or how much power is in a hertz. But that's not true. In superconductivity, you have to initiate the harmonics of that. Okay? We have a tremendous amount of harmonic resonance in heterodyne magnetic induction. Okay? Let me explain that to you. So now we're at 47 volts in that, so we have absolutely no voltage drop whatsoever. 9/10 of a volt. Okay? So let's go to hertz. Okay? Remember, my input hertz are here. There's my output hertz. Well, watch what happens. We're just going to leave everything saying. All we're going to do is turn up the potential here. Okay? Just a little bit. Watch what happens. You're at 100% duty cycle. That's perfect over unity power. Okay? .6 volts hertz. Now watch what happens. Just gonna raise the potential a little bit as this dynamo speeds up. I'll explain that in a moment. Okay? Still no input hertz. We're going to go to volts. Input volts are 52. Still quite a bit of power. At 51.8, 52.5. Very nice. Okay? Now watch what happens. Now we're going to turn down the speed. Even though the motor is going slower, the hertz are gone up. Now watch what happens. Look at my duty cycle. Now we can go the other way, defeating all reactive power, producing pure active power. There's the volts in, and there's the volts out. Running this motor and this light. Okay? At 2.5 amps. So watch what happens. duty cycle, volts again. Now we're just going to go up right to there. There's our hertz. There's our percentage. We're going to go up one more. There's 100% right there. Yeah, I'm sorry, it was 40.8, 41.8. That is the sweet spot. That's all the power that you ever need to produce from a power plant. You don't need to produce 120 volts. You only need to produce 41 volts. Let me show you. Here is the hertz, the 100% duty cycle. Now we're going to switch a load. Those bank of capacitors are in series with this light and this load to give a brunt. Watch what happens. I'm just going to turn on the light. And look what happens. The duty cycle goes away. In this power, giving pure reactive power over the grid. Instantly. 100%. Any load, any time. Perfect power. Now, if you want to add a little brunt to that, all you have to do